Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will see some theorems which are without proof. Theorem 8 is, statement of this theorem is, a non-decreasing sequence which is not bounded above diverges to infinity. That means non-decreasing means increasing sequence which is not bounded above is diverges, and it diverges to plus infinity. This theorem is without proof. Another theorem, theorem number 9, which is also without proof. Statement of this theorem is, a non-increasing sequence which is not bounded below diverges to minus infinity. A non-increasing means decreasing sequence which is not bounded below diverges to minus infinity. So objective questions there will be asked. That means a non-decreasing sequence which is not bounded below diverges to dash dash, that is minus infinity. Here diverges to plus infinity. Now we consider one theorem. Theorem number 10. Statement of this theorem is, the sequence in bracket, in another bracket is, in bracket 1 plus 1 upon n, bracket complete raised to n, and whole bracket bracket complete, and going from 1 to infinity is convergent. That is sequence 1 plus 1 upon n raised to n, and going from 1 to infinity is convergent. Let us consider the proof of this theorem. Let sequence Sn n going from 1 to infinity equal to sequence 1 plus 1 upon n going from 1 to infinity be a given sequence. We will prove that the sequence is non-decreasing and it is bounded above. We know that the binomial theorem a plus b in bracket a plus b bracket raised to n equal to nc0 a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2 plus dash 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 plus last term is ncn a raised to 0 b raised to n. We have studied this theorem in 11th standard. Sn equal to, here Sn equal to 1 plus 1 upon n raised to n, a equal to 1, b equal to 1 upon n. So that we get Sn equal to nc0 1 raised to n, 1 raised to n is 1, and b raised to 0, b means 1 upon n raised to 0, plus nc1 1 raised to n minus 1 is 1, and second term 1 upon n raised its power is 1, plus nc2 1 raised to n minus 2 is 1, and second term power is 2, 1 upon n raised to 2, plus nc3 1 raised to power a raised to n minus 3, here n minus 3 must be power, and second term power of, here one term is there, so its power, any power it will become 1, and second term 1 upon n its power is 3, plus dash 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 last term is ncn 1 raised to 0 into, that is a raised to 0, a raised to 0 last term is, and b raised to n, that is 1 upon n raised to n. After simplifying we get this is Sn equal to 1 NC0 is 1, this term is 1 upon n, anything raised to 0 is 1, plus NC1 is n into 1, and 1 upon n raised to 1 is 1 upon n, plus NC2 is n into bracket n minus 1 upon 2 factorial into 1 into 1 upon n square, plus NC3 is n into bracket n minus 1 into bracket n minus 2 upon 3 factorial into 1 upon n cube, plus last term NCn is 1 into 1 raised to 0 is 1 into 1 upon n raised to n. It is equal to, after simplifying we get 1 plus 1 plus n into bracket n minus 1 upon 2 into 1 upon n square, plus n into bracket n minus 1 in bracket complete into in bracket n minus 2 upon 6 into 1 upon n cube, plus dash 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 plus 1 upon n raised to n. After simplifying we get this is equal to 1 plus 1 plus n into n is n square. It is taken outside, so that we get 1 minus 1 upon n upon 2, and this 1 into 1 upon n square, plus n, so that take n cube common. In bracket we get 1 minus 1 upon n bracket complete, and in second bracket we get 1 minus 2 upon n upon 6, and into this term 1 upon n cube, plus dash 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 last term is 1 upon n raised to n. After simplifying this we get this is equal to 1 plus 1 plus up to 1 minus 1 upon n upon 2, plus in first bracket 1 minus 1 upon n into in second bracket 1 minus 2 upon n upon 6, plus dash 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 plus last term is 1 upon n raised to n. Hence Sn equal to 1 plus 1 plus 1 minus 1 upon n upon 1 into 2, plus in first bracket 1 minus 1 upon n into in second bracket 1 minus 2 upon n upon 1 into 2 into 3, plus dash 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 plus 1 upon n raised to n. These are n plus 1 terms. K plus 1th term of Sn is K plus 1th term of Sn is 1 in first bracket is 1 minus 1 upon n bracket complete into in second bracket 1 minus 2 upon n bracket complete dash 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 1 minus k minus 1 bracket complete upon n whole bracket complete upon 1 dot 2 dot 3 dot up to k. Give this as number 1. Similarly, Sn plus 1 equal to 1 plus 1 plus 1 minus 1 upon n plus 1 bracket complete upon 1 dot 2, plus in bracket 1 minus 1 upon n plus 1 bracket complete into in second bracket 1 minus 2 upon n plus 1 upon 1 dot 2 dot 3. That means put n equal to n plus 1 in Sn, so that we get Sn plus 1, and last term is 1 upon n plus 1 raised to n plus 1. These are n plus 2 terms. K plus 1 term of Sn plus 1 is, put n equal to n plus 1 in this K plus term of Sn, so that we get K plus 1 term of Sn plus 1 is in first bracket 1 minus 1 upon n plus 1 into in second bracket 1 minus 2 upon n plus 1 bracket complete into dash 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 last bracket is 1 minus k minus 1 upon n plus 1 bracket complete upon 1 dot 2 dot 3 up to k. Denote it as number 2. From 1 and 2, from 1 and 2, from 1 and 2 we get Sn is less than or equal to Sn plus 1, Sn plus 1 less than or equal to Sn plus 2, Sn plus 2 less than or equal to Sn plus 3. This implies Sn is less than or equal to Sn plus 2, less than or equal to Sn plus 2, less than or equal to dash dash dash. That means this proves that sequence Sn and going from 1 to infinity is non-decreasing sequence. That means this sequence is non-decreasing, that means increasing sequence. Now consider, now we have to prove that sequence Sn is bounded. So that we consider Sn equal to 1 plus 1 plus in bracket 1 minus 1 upon n upon 1 dot 2 plus in first bracket 1 minus 1 upon n bracket complete into second bracket 1 minus 2 upon n bracket complete upon 1 dot 2 dot 3 plus up to last term is 1 upon n. So that Sn is less than 1 plus 1 plus 1 half plus here 1 by 6 and 1 by 4, it is less than 1 by 4 plus next term will be less than 1 by 8 plus last term is 1 upon 2 raised to n, that is it is less than 1 upon 2 raised to n. Sn we can write Sn is less than 1 plus in bracket 1 plus half plus 1 by 4 plus 1 by 8 plus up to plus 1 upon 2 raised to n bracket complete. So that Sn is less than 1 plus 1 into bracket 1 minus 1 half raised to n bracket complete upon 1 minus 1 half. Here common ratio is half, first term is 1. So by the rule of sequence we can take 1 into bracket 1 minus 1 half raised to n upon 1 minus half. So that Sn is less than 1 plus 1 minus 1 half raised to n upon 1 minus half is half, and after dividing 1 half we get here 1 half raised to n, taking limit, this limit will be 1 half raised to n will be 0, so only one terms remains 1 upon 1 half. That means Sn is less than 1 plus 2, 1 upon 1 half, that is 2, 1 plus 2, that is Sn is less than 3. This proves that sequence Sn is bounded above. Thus we have given sequence is non-decreasing sequence, given sequence is non-decreasing sequence and it is bounded above sequence. So that we have proved that given sequence Sn 1 plus 1 upon n raised to n and going from 1 to infinity is non-decreasing sequence and bounded above, so that the sequence is convergent by theorem 6. Now we consider some rules on the convergent sequences. Operations on these convergent sequences. Here consider two sequences, sequence Sn and sequence Tn. If sequence Sn and going from 1 to infinity and sequence Tn and going from 1 to infinity are sequences of real numbers and C belongs to R, then sequence Sn n going from 1 to infinity plus minus sequence Tn n going from 1 to infinity is the sequence Sn plus Tn n going from 1 to infinity. And second operation is, if sequence Sn n going from 1 to infinity into sequence Tn n going from 1 to infinity is the sequence Sn dot Tn n going from 1 to infinity. And third operation is, C into sequence Sn n going from 1 to infinity is the sequence C into Sn n going from 1 to infinity. Here we have discussed these three operations on convergent sequence. First operation is addition or multiplication of two sequences. Second operation is on multiplication of, first operation is addition or subtraction of two sequences, second operation is on multiplication, and third operation is on multiplying by a constant. So that the sequences, after taking these operations plus minus, becomes Sn plus minus Tn n goes by 1 to infinity. Taking operation multiplication, sequence will become Sn dot Tn n goes by 1 to infinity. After multiplying C, sequence will become C into Sn n going from 1 to infinity. Thank you.